one. What is the maximum vertical distance between the line y equals x plus 2 and the parabola y equals x squared? And we're restricted to find the vertical distance between the domain of -1 and 2. I went ahead and drew a picture, little sketch here of y equals x squared. That's this black one here. So that's y equals x squared. And then I also drew the line y equals x plus 2, y-intercept here with the slope. And we need to do the distance between these two, the maximum between -1 and 2. So I'm picking the maximum as here illustrated by this yellow line. That's the maximum distance. You can choose other points, but it looks like the maximum distance is there. It actually could also be in here, but I chose here. So what we're going to do is, if you had our x's are the same, so to find the distance, so if I had to find the distance between say 3 and -1, we know that distance is 4. And what you're doing is you're subtracting, you're taking 3 minus a -1. That gives you 4. So basically we're wanting this distance here. So we're just going to subtract x squared from x plus 2. All right, so we're going to let our vertical distance be defined as vertical distance. So I'll just write v of x equals our x plus 2, and then subtract your x squared, because these are actually your y values you're subtracting. All right, and again, our restriction is from -1 to 2. Since these are included, I'm going to use the closed interval method to find the critical numbers and evaluate the endpoints of the interval to see if those would be a maximum. We could tell by the graph that they're not, but we'll do that. So basically, let's take our derivative of our vertical distance function, and we're going to get, this is going to be just 1 minus this part is going to be 2x. Set this to 0, and when you solve, you're going to get our critical number is 1/2. So using our closed interval method, we're going to evaluate f of -1 for this endpoint. F, not f, we're going to do v, sorry. So v of -1, v of 1/2, and v of 2. And whatever is the bigger number is going to be your maximum. So if you plug in -1, you're going to get 0. And if you plug in, and I'm plugging it in here, if you plug in 1/2, you're going to get 9/4. If you plug in 2, you get 0. Therefore, there's an absolute maximum at x equals 1/2. And to find that distance, you plug it back into our vertical distance function. So it's going to be v of 1/2 equals 1/2. We already figured it out, but 1/2 plus 2 minus 1/4, which equals 9/4. So the maximum distance is 9/4. And that's it. Thank you. Have a nice day. Bye-bye.